All right, so part 2, we're going to deal with perfect square trinomials. And these are kind of tricky, so pay close attention. The first thing you would ask yourself, when you have 3 terms, and you can do this anytime you have 3 terms, okay? Anytime. I want you to look at the first and last term. And I want you to ask yourself, is everything in the first and last terms a perfect square? Is it a perfect square? Look at that first. Then I want you to ask yourself, can I write the middle term? And I'm going to, let's see, we'll do the middle term in red. Middle term. Can I do the middle term as 2 times the root of the first and the root of the last? So 2 times the root of the first and the root of the last. And you'll see what that looks like in just a minute. And if that's true, if both of those things are yes, I can do it, then my factors is actually going to be the square of the, sorry, this is weird, square of the roots of the first and last terms. What, Miss Chiefy, what are you talking about? Let's take a look. This will be easier when you see it in action. So come on down with me to number 79. Okay, so we have a trinomial that we need to factor. So the first thing I'm going to look at is my first term and my last term. Are they perfect squares? Let's see. R squared can be written as R times R. Okay, so R squared can be written as R times R, and since these are the same, that's the square root. So that's a perfect square. 1 can be 1 times 1, so that's a perfect square. So right now, all my red flags are going off that something is special about this trinomial. The other thing I need to check is, can I write the middle term? Is it 2 times the root here, which is R, and the root here, which is 1? 2 times 1 is 2, and R is R, so 2R. Do these match? Yes, they do. So if you can write this middle term as 2 times the root from the first and times the root from the last, and it matches your middle term, then this is a special trinomial, and here's what you're going to do. You are going to, this is so awesome, you are going to use the root from the first term, which is R, the root from the last term, which is 1. They're going to be in a binomial, okay? Well, how are we going to connect them, Miss Chiefy? Look at this sign right here. That's the sign you're going to use. So that comes down, and then we square it. Done. There it is. I know it's kind of confusing, okay? But you can do it. First thing, you look at your 3 terms. Look at number 80. First 3 terms. Look at number 1 and number 2. This can be written as n times n. This can be written as 3 times 3. So yes, they are perfect squares, okay? Now I want to know, can I write my middle term as 2 times the root here, which is 3, and the root here, which is n? 2 times 3 is 6, times n is n, so 6n, 6n. These match. So this is a perfect square trinomial, which means I can take n and 3. I'm going to join them using the first sign. Whatever that first sign is, that's what goes in the middle. Pop them in parentheses and square it. And there you have it. That's how you factor it. Now, what if you don't see it? What if you don't see that this is a perfect square and you're like, I'm so lost, I have no idea what you're doing right now? That's okay, because check it out. If I do this with my x method, and I say, okay, my x, it's got to add up to 6. It has to multiply together to be 9. That's going to be 3 and 3. So I'm going to split my middle term with 3 and 3 as my magic numbers. And I'm going to factor this group, n times n plus 3. Factor this group, 3 times n plus 3. Watch what happens. What happens is your twins are n plus 3, and your loners are n plus 3 also. They work out to be the same. And so since we have this times itself, it's n plus 3 times n plus 3, we can write that as n plus 3 squared. So that's where this is coming from. So if the special pattern is throwing you for a loop, use your X. That's fine. Or use your X to check yourself. All right, if you're like, I hope I did that right, but I'm not really sure, do the X. Let's take a look at number 81. All right, first term, last term. Whoa, neither one of those is a perfect square, Miss Chiefy, because there's a 3, and 3 is not a perfect square. But 3, 30, 75, I can factor that 3 out. Then I have v squared minus 10v plus 25, and that is awesome. Now I'm going to look to see with my trinomial, is this a special trinomial? This and this. This can be v times v, this can be 5 times 5, so far so good. Can I write my middle term as 2 times the root times the root? Is this 10v? Yes, they match. So that means I need a v and I need a 5. I'm going to join them with the first sign, whatever that first sign was. In this case, it's minus. I'm going to square it. And then don't forget to bring down your greatest common factor. If you factor 1 out, it has to come down to your final answer as well. And there you have it. Okay? So don't be afraid of your special pattern. Try to do it by your special pattern because it's going to help you later when we try to go backwards. But if you can't get it, use the X. Check yourself, it's fine. Why don't you pause the video and try 82 on your own? This is what I want you to do. I want you to look for a GCF. Look at your trinomial. See if it's a special trinomial. That means follow your steps up here. First and last terms, are they perfect square? Middle term, is it 2 times the root times the root? Does that give you your middle term? Then try to set up your binomial and square it. Okay, so pause the video, come on back when you think you've got it. How'd you do? Did you get it? Don't worry. If you're struggling, come to class, bring your questions, put a big old star by it, and we'll go over them together.